Welcome back. We're continuing to write the equation of a function in slope-intercept form. Now, we went from using our y notation to functional notation, and in the previous section, we were given the slope of a line and the function evaluated at some point. And from that, we derived our functional notation in our slope-intercept form. So in this section, we're actually not going to be given the slope, but we're going to be given two evaluations of our function at two different points. So let's take a few examples. Let's say we're given the following information. F of 4 over 3 equals minus 1, and we're also given the evaluation f of minus 3 equals minus 4. Okay, now don't get excited here. We're actually given the values of our function evaluated at 2 points. We know how to write an equation when given 2 points. All we need to do is we need to realize that these are in fact evaluations, and they're in fact 2 points, just in functional notation. So we have a point here and a point here. Okay, so right here is our function evaluated at x equals 4 over 3, so x equals 4 over 3, and since we're using, well, this is x, and this was y, but we found out in the previous section that y equals f of x. They're interchangeable, we're just switching notation, so f of x is minus 1. And same thing here, x is minus 3, and the function f of x evaluated at minus 3 is minus 4. So we have 2 points here. So all we need to do is find the slope, and we should actually be pretty good at this by now. We know the slope m equals the change in our y coordinates divided by the change in our x coordinates. So let's go ahead and find that. We have minus 1 minus a minus 4 divided by the change in our x coordinates, 4 over 3 minus a minus 3. Minus 3. Okay, so we can cancel these negative signs, which is always good. We have 3 on the top, and we have, well, let's rewrite this because we have a fraction, 4 over 3 plus, let's rewrite 3 as a rational number, 9 over 3, so we can add these in the next step. We still have 3 on the top, we have 13 over 3 on the bottom when we combine our fractions, and we know how to deal with this when we're dividing by a rational number. We rewrite the top. We don't ask why, but we flip the second and multiply. So we have 3 over 13, which equals 9 over 13. So this is our slope. So now we have the slope of the line along with one point, or actually we have 2 points, but we only need 1. So we can plug these points, one of the points and the slope, into our equation and solve for our y-intercept. Okay, so let's go ahead and do that. We have y equals mx plus b, but we're using functional notation, so f of x equals mx plus b. Let's go ahead and pick one of the points. These have 2 negative numbers, but I'd rather have that than deal with a fraction. So let's use this point. Okay, so minus 4 equals, our slope is 9 over 13 times x. X is minus 3 plus b. B is what we want to solve for, so let's go ahead and move everything else to the other side. We have minus 4 equals 9 times minus 3 is minus 27 over 13 plus b. We can isolate b by adding our fraction to both sides. So we have 27 over 13 minus 4 is the same as 52 over 13. So now we have a common denominator, and that gives us a negative 25 over 13 for our b. So this is the y value of our y-intercept. So now we can go ahead and use all this information, put it together, and write the equation of our function in slope-intercept form. So we have f of x equals, our slope is m, so 9 over 13 x plus b. B is a minus 25 over 13. And that's our answer. This looks a little complicated just because we're dealing with fractions and we got some ugly numbers, but we need to get used to that because ugly numbers are actually a way of life in the real world. Not all the numbers are actually round, nice and round and perfect. So let's go ahead and do a few more examples. We have the following information. We have f of minus 2.5 equals 4, and f of 1 equals minus 2. Okay, let's write these two evaluations of our function as 2 points. So our first point is our function is being evaluated at x equals minus 2.5. So let's go ahead and rewrite x as a fraction. Let's call it minus 5 over 2. I don't really like using fractions, but I'd rather have them than the decimal. And f of x evaluated here is 4. We have 1 point. Let's find the other one. X equals 1. F of x equals minus 2. So now we have 2 points to plug into our slope formula. So let's go ahead and find the slope. We have 4 minus a negative 2 divided by minus 5 over 2 minus 1. We can cancel these negative signs. Instead of subtracting, we can add a negative. We have 6 on the top. Let's go ahead and change a negative 1 into a negative 2 over 2. So we can skip a step here and just go on to subtracting or adding, however you want to look at it. So we have minus 7 over 2, which we can take care of this by flipping the denominator. So 6 over 1 times a negative 2 over 7. That gives us minus 12 over 7, and this is our slope. Okay, so we also know how to solve for our y-intercept when we're given the slope and at least 1 point on the line. So let's pick a good point. This looks a lot better than this one, so let's use this point. So f of x, which is minus 2, equals m, which is minus 12 over 7, times x, which is just 1, plus b. This is our slope-intercept form. We're just substituting in and solving for b. So we have minus 2 equals minus 12 over 7 plus b. Let's go ahead and isolate our variable. Let's add this minus 12 over 7 to both sides. So we have b equals 12 over 7 minus 2. Let's go ahead and convert this into minus 14 over 7, so we can go ahead to subtract these rational numbers. 2 is the same as 14 over 7. This gives us a minus 2 over 7. Okay, so we have our b, our y-intercept, our slope, and a point. We don't need the point anymore, but since we have a slope and we know what b is, we can write the general equation in slope-intercept form. So we have f of x equals minus 12 over 7 times x plus b. b is a negative 2 over 7. And that's the equation of our line. Not a whole lot to it. We basically should know how to do most of this already. We're just getting used to the functional notation. Let's look at another one. Let's look at one more. We have time and space to do one more. Let's say f of 1 equals 5 and f of minus 1 equals minus 5. Okay, so we have our function evaluated at 2 points, so let's go ahead and write out those 2 points. X is 1, f of x is 5, x is minus 1, and f of x is minus 5. We're going to need our slope, so let's go ahead and find that. We have 5 minus a minus 5 divided by 1 minus a minus 1 minus 1. Oh, computer's freezing up. Okay. Let's cancel the negative signs in the top and the bottom. So we have 10 divided by 2, which is the same as 5, so our slope is 5. Now we simply need to use this slope and pick out one of our points to plug into our general equation so we can solve for our y-intercept. The numbers are the same, but these are positives and these are negatives. I'd rather deal with positives because I tend to lose negatives. So let's go ahead and use this point right here. We have f of x, which is 5, equals mx, so 5 times 1 plus b. Plus b. We want to isolate b, so we have 5 equals 5 times 1 is 5 plus b. Subtract 5 from both sides, and we have b equals 0. So our y-intercept is 0, which means this function runs through, we actually know another point, it runs through the origin. So we know 3 points now, which is really cool. We still want to use one of these just so we can add some add to our functional notation. So we have the slope-intercept form, the general equation, f of x equals 5x, and our y-intercept is 0. So f of x equals 5x is our general form, our functional notation of the equation of the line that passes through these 2 points, also passes through the origin. And you can check that because if you plug in 0 for x, the function equals 0. 5 times x is 0. Okay, so we're using functional notation and we're writing the equation of a function in slope-intercept form. So get used to this, get used to functional notation, go over this video and the one before it a few times and get some good practice on it so we can move on. I'll see you soon.